So in lesson 8.5, we're going to talk about angles of elevation and depression, and then how we solve very similar to our 8.4 problems, but using the description given to us with angles of elevation and depression. So an angle of elevation is like we're looking up, and so elevated, so upward. Here's kind of our line of sight, and if we're going to look up, then we have an angle of elevation. If we're looking down below kind of our eyesight, where our eyes are horizontally then down, that's going to form an angle of depression. So depression down, elevation up. So let's go ahead and identify angle 1 here. That is going to be an angle of, again, we're kind of looking below the horizontal, so that would be depression. And then angle 4 is going to be this angle right here, which there's our horizontal, and it's formed by this line that is above that horizontal, so that would be elevation. Elevation. So we're going to use kind of our same stuff that we did before, what we know, what we need, what we're going to use then, what trig ratio. But let's go ahead and draw a quick little picture to kind of help us. So we have a tree, and then we have our casting a shadow, and we are going to figure out what the height of the tree is. So x here, we know that the shadow is 9 meters long, and we know that the elevation, the angle of elevation is going to be 52. So if this is 52 here, degrees for our angle of elevation, we can go ahead and figure out the height of the tree. So angle, we know the adjacent, we want the opposite, so knowing A, we need the opposite, and we're going to use OA, so tangent 52 is equal to our O over A, which we'll just put tangent there and we'll set up our ratio over here. So tangent 52 is equal to O over A. So we're going to just go ahead and multiply those together, because we're doing cross multiplication in a sense, right? So x is equal to 9 times tangent 52. Make sure you're in degree mode. And x is approximately, make our squiggly, 11.5 feet tall. So on the next one, we're going to have our angle of depression. So we've got our swimmer here. And 14 feet above the floor. Should probably put some legs. There we go. And then we have our angle of depression of 38 degrees. I should probably kind of make that more like that. There we go. Okay, so that's going to mean that by alternate interior, this angle here is 38 degrees. And we want to figure out what how far from the turtle. So here's our turtle. And we want to figure out what that distance is. So we know, here's our angle. We know opposite, and we need the hypotenuse. So we know the O, we need the H. So we're going to use sine 38. It's equal to our O over our H. O is 14, H is unknown. So then we can go ahead and switch those. So x is going to be equal to 14 over sine 38, which is kind of the same thing as cross multiplication, just a little quicker. And so when we type that into our calculator, we're going to get about 22.7 feet from the turtle. So this next example here, we've got a picture already drawn for us, which is nice. We have a roller coaster, 55 degrees here. We want to figure out what the height is. So unknown is right there, our height. So this would be the opposite. And then we have the hypotenuse. So we know the hypotenuse. We need the opposite. So we're going to be using sine. Sine 55 degrees equals our O, which is x, over our h. So on this one, we're going to take and multiply 98 times sine 55 to equal x. So x equals 98 times sine 55. And I'm just not putting the 1 under here because we know it's there. And so x is equal to 80.3 feet high for that roller coaster. Okay. So on this next one, we have a couple of different triangles we're looking at here. We know our angle here, and we know our opposite. And it looks like we're trying to figure out this adjacent here. So we know our O, we know we need our A, so we're going to be using tangent. So tangent 27 is equal to our opposite over our adjacent. Now, we actually have a little bit more than just our 25. We actually have our 5.5 that we need to add to that height here because our whole angle actually goes up to this point. So really, we're up 30.5. So it's going to be x equals, because we're going to switch those, 30.5 over tangent 27. So the audience member's about 60 feet away. So if you want to try this next one on your own, go for it. And then push play and check when you're ready. And hopefully you got the seals about 31 feet from the cliff. Our last one has got 2 dolphins here with 2 different degree measures. Whoops. And so we are going to kind of calculate both. Let's start with for dolphin J, that one is going to be, let's see what degrees that one is, 35 degrees. And then dolphin K is going to be 36 degrees. So now we are going to be using the same height here of 154, and once we figure out how far away they are, we can do the difference and figure out how far apart they are. So let's start with what we know for dolphin J. We know the opposite. So again, this angle up here, alternate interior, is going to give me that angle there for, so 35. So we know the angle and we know its opposite, and we're trying to find the distance here, the adjacent. So O and A, and we're going to be using that for each of these. We know the O, we need the A, so tangent for both. So this one is tangent 35 equals the opposite 154 over the adjacent, the unknown x. This one over here is tangent 36 equals 154 over the unknown. So we're going to switch those, and so it's x equals tangent 35 on the bottom. So 154 divided by tangent 35. So that one would give us 219.9348. And this one is going to give us, we divide 154 by tangent 36. That is going to give us 211.9628. And then we're going to subtract. So when we subtract those, we are going to get, so k minus j, or j minus k. So we don't have a negative there. It's 7.972 meters is their distance apart from each other.